If you're running security monitoring in Azure and you're only looking at logs, you're missing a significant portion of what's actually happening on your network, and that blind spot is exactly where attackers love to hide.
Wait, a significant portion? That seems like a huge gap. What are we missing if we're just using logs?
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm your host, and today we're diving into something that most Azure admins don't even know exists but absolutely should.
Hey everyone. Yeah, I'll admit I had no idea Azure could do actual packet-level traffic mirroring until about a week ago.
That's exactly why we're covering this today. But I need to give you a really important caveat right up front. The feature we're discussing, Azure Virtual Network TAP, has been in limited public preview since 2018 and requires explicit approval from Microsoft to use. Most Azure customers can't just enable this today. That said, understanding how it works is valuable, and we'll also cover alternatives you can actually use right now.
Oh wow. So this isn't something I can just turn on in my subscription?
Not without going through Microsoft's approval process. You need to email azure-networking@microsoft.com and register the feature provider. But let's talk about why this capability matters and how it works, because the concepts apply whether you're using VNet TAP or other solutions.
Okay, that makes sense. So what's the problem with just using logs?
Traditional logging captures metadata, connection events, maybe some flow records, but it doesn't capture the actual packet contents, the payloads, the raw bytes flowing between your VMs.
Okay, so if I'm looking at NSG flow logs, I can see that VMA talked to VMB on port 443, but I can't see what they actually said to each other?
Exactly right. And that matters because sophisticated attacks often look completely normal at the metadata level. A compromised VM making HTTPS calls to an external IP? That's just Tuesday for most workloads. But if you could see the actual packet contents, you might notice data exfiltration, command and control traffic, or lateral movement attempts.
So how does Azure Virtual Network TAP solve this? Is it like putting a wiretap on the network?
That's actually a perfect analogy, and it holds up technically. TAP stands for Test Access Point, which comes from physical network taps that literally splice into cables to copy traffic. Azure's Virtual Network TAP does the same thing virtually. It creates a copy of all traffic flowing to or from a specific network interface and sends that copy to a destination you specify.
So every packet that hits my VM's NIC gets duplicated and sent somewhere else for analysis?
Precisely, and here's the key architectural detail. The TAP mirrors traffic at the virtual NIC level within Azure's software-defined network. The mirrored traffic gets encapsulated in VXLAN with a specific VNI, virtual network identifier, that you configure, and sent to your collector. Now, this is different from physical taps where you'd get raw Ethernet frames with VLAN tags and such. Azure's virtual networking abstracts away those layer 2 physical network details.
EBCA and encapsulation. So the collector needs to understand how to decapsulate that, right? What would I actually use as a collector?
Great question. Your collector needs to be able to receive VCX lane traffic on UDP port 4789, which is the IANA assigned port for vSLAN. Common options include network virtual appliances from vendors like Gigamon or Ixia, or you can use open source tools like NTOP Pong or Zeek, formerly known as Bro, running on a Linux VM. The collector must be in the same region as your TAP source, and it needs an internal load balancer in front of it for high availability.
Wait, why an internal load balancer specifically?
Because the TAP destination must be an internal load balancer front-end IP, not a VM directly. This is an Azure architectural requirement. The load balancer distributes the mirrored traffic to your back-end collector VMs. You configure it with HA ports, which means all ports and protocols, so nothing gets filtered out.
Okay, let me make sure I understand the setup. I have a VM I want to monitor. I create a TAP configuration pointing at that VM's network interface. Then I specify an internal load balancer as the destination, and behind that load balancer I have my collector VMs running something like Zeek?
You've got it exactly right. And here's a critical detail. The TAP and the monitored NIC must be in the same region. But since this is a limited preview, there are additional restrictions. You need to register the Microsoft.network/allow virtual network tap feature using register Oz provider feature and wait for approval. There are also limitations on supported VM sizes and region availability that you'll need to verify with Microsoft.
What about the performance impact? If every packet is being copied, doesn't that add latency or consume bandwidth?
This is where people often get it wrong. The TAP operates asynchronously. The original traffic flows normally with no added latency to your application. The traffic mirroring is handled by the Azure host's virtual switch at the hypervisor level, not by your VM CPU. However, you do need to account for the bandwidth. If your VM generates 1 gigabit per second of traffic, you're now generating an additional 1 gigabit per second of mirrored traffic to your collector. Your collector infrastructure needs to handle that throughput.
So I could accidentally double my network costs if I'm not careful?
Absolutely. And here's mistake number one I see constantly. People enable TAP on high traffic production VMs without sizing their collector appropriately. The collector gets overwhelmed, starts dropping packets, and now your security monitoring has gaps anyway. Always calculate your expected traffic volume first. Use Azure Monitor metrics to understand your current NIC throughput before enabling TAP.
What's the second common mistake?
Not filtering at the collector level. TAP gives you everything, every single packet, but you probably don't need to store or analyze all of it. Configure your collector to filter and prioritize. Maybe you only care about non-encrypted traffic, or traffic to specific subnets, or connections on unusual ports. Zeek is excellent for this because you can write scripts to extract exactly what you need.
This sounds really powerful for security monitoring. What are the main use cases you've seen in production?
3 big ones. First, intrusion detection. Running tools like Suricata or Snort against the mirrored traffic to detect known attack signatures. Second, forensic analysis. When an incident occurs, you have full packet captures to understand exactly what happened. Third, compliance support. Packet capture capabilities can help with regulations like PCI DSS by providing deeper visibility into network traffic. To be clear though, PCI DSS doesn't explicitly require full packet capture. It requires network monitoring and anomaly detection, which you can achieve through various means. But having packet-level data can definitely strengthen your compliance posture.
Now, you mentioned earlier that VNet TAP is in limited preview. What can the rest of us actually use today?
Great question, and this is really important. For generally available options, you've got several choices. Azure Network Watcher has a packet capture feature for on-demand captures on specific VMs. It's not continuous like TAP, but it's great for troubleshooting and incident response. NSG flow logs combined with traffic analytics give you rich metadata about your network flows. Third-party network virtual appliances from vendors like Palo Alto or Fortinet can perform traffic inspection and mirroring within your virtual network. And Azure Firewall with logging enabled provides visibility into traffic flowing through it. For most organizations, a combination of NSG flow logs, Network Watcher packet capture, and a good SIEM integration will cover the majority of security monitoring needs.
Let me recap what I learned. Azure Virtual Network TAP creates a copy of all traffic on a specific NIC, encapsulates it in VXLAN, and sends it to an internal load balancer fronting collector VMs. It adds no latency to production traffic, but does consume additional bandwidth. However, it's been in limited preview since 2018 and requires Microsoft approval to access. For most of us, alternatives like Network Watcher packet capture, NSG flow logs with traffic analytics, or third-party NVAs are the practical options available today.
Perfect summary. My pro tip? Start with NSG flow logs and traffic analytics if you haven't already. They're GA, they're relatively easy to set up, and they'll give you solid visibility. If you need deeper packet-level analysis, look into Network Watcher's packet capture for specific investigations, or evaluate third-party NVAs that can provide continuous traffic inspection. And if you really need TAP's capabilities, reach out to Microsoft to discuss getting into the preview.
That's really practical advice. I'm definitely going to set up traffic analytics in my environment this week.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone who's working with Azure Security Monitoring.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.